Hi, this is Lori, and welcome to my project on using a PIR sensor with the Raspberry Pi. The final part of our project will include a kitty disco. So a PIR sensor stands for Passive Infrared Sensor, and they look like this. You typically get them in an electronics kit to get started. The model actually is HCSR501, and it has 3 pins, a power pin, a ground pin, and then an output pin, which usually puts out a 3.3 volt pulse. And when it detects motion, it'll go high, and when there's no motion detected, it'll be low. There are 2 potentiometers you can see in the bottom here of the device that you can adjust the sensitivity or range of the potentiometer, and then one also to adjust the timing. And then there's also a jumper over here which we can use to select between an H or repeat mode and an L or single trigger mode. So how it works is if you take the little dome or Fresnel lens off of it, you can see the actual sensor. And it has 2 slots in the top of it. And what it does is it compares the infrared signal between the 2 sides. And if it sees a difference, that triggers the output pin to go high. So, it needs to be a warm object like a person or an animal passing through that would cause a difference in the IR signals of those 2 halves of the sensor. And again, that's what causes it to go high and signal that there's something there. So it took me a while to figure out how these potentiometers and jumper worked and what the different modes actually did. And this is the best I could get it down to after reading quite a few data sheets and tutorials on this sensor. In the L or single trigger mode, the sensor goes high after it senses something, a person or an animal, and then for that set delay time set by our potentiometer, it will wait and then go low again. When it's up high for that delay time, it will not continue to sense. So that's the single trigger. So, it goes high, it stays high for the delay time, then comes back down. It could be re-triggered again after that. In the repeat mode, the sensor goes high, again, after sensing something, and it continues sensing. So it keeps watching, and it'll continue to stay high as long as it continues to detect motion. But once that motion is no longer detected, it will go low after the set delay time. So once it detects no more motion, it'll stop and start timing and then go low. So that's my understanding of how it works. And based on the data sheets I read, I got varying numbers here, but delay times seem to be able to be set from 5 to 300 seconds. And then varying numbers in various data sheets for these sensors, but the range seemed to be somewhere between 0 and 7 meters being the range of this sensor. So here's the circuit for connecting up the PIR sensor. And you can see here it is, and it has the 3 pins, power, ground, and then the output pin. Likes to be powered by 5 volts, so we'll take 5 volts off of the Raspberry Pi and get a ground rail. We'll power and ground the sensor, and then connect the output pin to one of the GPIO pins on the Raspberry Pi. So now let's take a look at some code of how you would interact with the sensor. So now I'll go over the program that I wrote to use the PIR motion sensor with the Raspberry Pi. But I also thought I'd take just a minute to say how I put this onto a breadboard. So you can see here is the device, and you can see that it has these pins right there, but you can't plug them directly into the breadboard because the capacitors here are in the way. So what I did was I took some stacking headers, cut them off so there's 3 of them, and then put that on here. On there we go. And then that allowed me to put it directly into the breadboard for prototyping. So that may be useful to you. All right, so back to the program. We'll load in the modules that we need. We'll set up the board numbering system. And then you can see here we'll assign the output pin of the PIR sensor to one of the GPIO pins, and we'll set that up as an input. And then we need to sleep for a little bit to let the sensor initialize. And it has to go out there and scan and get the base IR signature of the space that it's looking at. And when you look at the data sheets, it says anywhere from a minute to 2 minutes. I'm only doing 10 seconds here, but it does seem to work. But maybe to be better operation, you might want to make that a little bit longer. And then the while true loop's pretty simple. We'll read the motion pin from the sensor. We'll assign that to a variable called motion. We'll print that to the screen, and then we'll sleep for 1/10 of a second, and it'll keep going until we do a keyboard interrupt and do our GPIO cleanup. So let's see it go. I'm going to go ahead and kick it off here. So now we're going to wait 10 seconds for the sensor to initialize, and we'll know once it starts printing output to the screen. There it goes. So right now it's detected no motion. Now it's behind me, so I'm going to walk over there or slide over there and trigger it, and then hopefully we'll see some ones come across the screen. And there we go. So pretty simple and easy to use. So now for the Kitty Disco project. So we'll show the circuit here. And so the concept is to combine the infrared sensor with some LEDs and a couple of servos. Now these LEDs that I have actually are shaped like kitty cats. They're actually RGB LEDs, but they're not controllable. They just kind of cycle through all the colors. They're really, really cute. So they'll be here, and we got them connected up to the Raspberry Pi here and grounded, and current limiting resistors put in place. Got our motion sensor connected just as before, and then we added in the 2 servos, and we have them connected in, and they're connected to GPIO pins here on the Raspberry Pi. And on the servo arms, I've attached a couple of 3D printed kitty cats that I have, and so on the arms they're going to move around and dance for us during the disco time. And the disco will start when it's activated by detecting motion over the motion sensor. So that's the layout. So let's take a look at the code that will operate all of this. So here's the code for the Kitty Disco project. So now we're just going to combine the sensor, those kitty LEDs, and the dancing cats that are going to be on the servos, as discussed in the circuit before. And in this case, for the servos, we'll need to import the GPIO 0 library to use the servo. And I'm going to make a link to a previous video where I discuss this in detail. But I use this because I can use hardware control for the servo, and that gets rid of any jitter on the servo arm. So it's very useful to use this library. We'll go ahead and use the BCM board numbering system. Just like before, we'll set up the motion pin and set that up as an input. Then we're going to have those 3 LEDs with the kitties on them, and there'll be outputs on those pins. And then this is code that sets up the hardware control for the servos and creates the servo objects. And then just as before, we need to let the sensor initialize for some period of time, 10 seconds in this case. And then we finally enter the while true loop. So you can see it's going to do just as before. It's going to watch the motion pin and read that and print that to the screen. But once the motion pin goes to high or 1, it's going to print Kitty Disco to the shell. It's going to turn on the LEDs, and then the dance of the servos will go on. So the little kitty cats will start dancing, moving around between their midpoints, min and max. And I have them reversed so that they're kind of facing each other and moving at the same time. They'll dance for a couple of rounds and then end their dance Then we're going to sleep for a little bit just so we can really appreciate the cool colors of the kitty cat RGB LEDs. Then we'll turn them off, say time to rest, and then we'll come out of that if statement and we'll sleep a little bit and continue sensing from the sensor. And we'll leave the program using the normal keyboard interrupt, turn everything off, and clean up the GPIO. So now let's see the kitty disco.